Hello, everybody. Mr. Rubo here. Today we're going to start 7.3, which are proving trig identities. And yes, I did say prove. We're doing some trig proofs. So if you go on page 5, you'll see all of our identities that we've been dealing with last chapter. They're coming back. Don't worry. So they're here to reference, but hopefully you still remember them. Okay. So the way establishing trig identities work is your goal is to make one side of the equation look like the other. So what I usually do is I draw a line. Okay. Now, because we don't know that these are equal, that's the whole point of us establishing that they are proving that they're equal. We can't do our normal solving rules where you add things to both sides or divide both sides. You work only on one side at a time and strictly with one side. Okay, so a few hints, which these hints are actually on page 6. You don't work on both sides. And you can't assume that the two sides are equal. That's what we're trying to prove. Okay. And a really big one is start with the more complicated side. Seems counterintuitive, but if you start with the more complicated side, you actually have more stuff that you can do. Okay. It kind of actually focuses you in a little bit more. And then if you get stuck, switch everything to sines and cosines using either the reciprocal identities or the quotient identities. And yeah, those are your big two things. Is start with the more complicated side, and if you need to, change everything to sines and cosines. Sometimes you need a common denominator if you're adding or subtracting fractions. And then also sometimes you might need to multiply by the conjugate to both the numerator and denominator. And then the big thing is don't try to take square roots or raise powers or add things to both sides or subtract things to both sides. It kind of goes back to that do not work on both sides. Okay. So if we go back to page 5 and go to this example here, we look and we see that the left side has more stuff. So I would say that is the more complicated side. So what we're going to do is we start using some identities. Well, I see a secant and I see a sine. So that means I'm going to change the secant to 1 over cosine. And so it's 1 over cosine times sine of theta. Okay. So now if I simplify this left side, I get sine of theta over cosine theta. And if you think about the quotient identity right above, we know that sine of theta over cosine of theta is tangent of theta, which is exactly what we were trying to prove. So there is our first trig proof. Okay. One of the things as well, keep in mind, always think about what you're trying to get to. So you can kind of see with number 1, I knew I was trying to get to tangent, and I know tangent, if you look back up here, if you forgot, tangent is sine over cosine. So that's important. I also know tangent is 1 over cotangent, right? So there's a few ways I could have gone, but because I saw a sine in there, I kind of knew I wanted to go the quotient. Okay. So let's go ahead and try number 2. All right, so for number 2, again, I like to draw the little line, reminding me I can't do stuff to both sides. Sometimes people want to multiply both sides by sine of x. We can't do that, okay? So we can only work on this one side. So when you look at this, tangent x cosine x sine of x all over sine of x compared to 1, well, the left side is definitely more complicated. So I'm going to start with the left side. And there's actually a few different ways you can do this problem. If you look at this and you see tangent and you're like, oh, well, let me just switch it to sine over cosine. Okay, so we would have this. So you have sine of x over cosine x times cosine x, and then all of this is over sine of x. So all I've done is replaced this with that. So using the quotient identity. Then once you do that, now it's just a bunch of algebra properties. So if you have cosine times cosine, or sine of x over cosine x times cosine x, it's really cosine x over 1, the cosines just cancel. and then you get sine of x over sine of x, because that's all you have left on the top is sine of x over 1, which is just sine of x, and then your denominator hasn't changed. And then you have sine of x over sine of x, which those indeed do cancel, and you get 1. And that works. Okay, so there's one way. I'm going to redo this problem and do it another way just to kind of see, maybe you saw it a different way initially, and it's okay if you see things differently. Try them out and see if you get it. If you get stuck, then go back and try it a different way. But if you saw this a different way, you might have been able to do it a little quicker. So if I look at this, and maybe some of you saw cosine over sine, and you're like, oh, I know that's cotangent. So you can rewrite it as cotangent x. And then you're like, oh yeah, tangent and cotangent, well, those are reciprocals, so I can rewrite this as cotangent x is becoming 1 over tangent x, and then look at that, they cancel, and you get 1 equals 1. So you could kind of see that way. I did it in 3 steps instead of, I think it was like 4 or 5 the last way. So when you look at, especially like when you look at my key, if you did it slightly differently, that's 100% fine. Just make sure that every single step, you're just doing one property at a time, and all of your properties make sense. All right, so then if we go to number 3, we have sine squared x times 1 plus cotangent squared x equals 1. So you look at this, and the shortcut or shorter way is if you recognize this, and the nice thing is we do have these right up here, so if you don't remember, 1 plus cotangent squared is equal to cosecant squared. So this is cosecant squared x times sine of squared x, or sine squared x. And then you're like, oh yeah, cosecant is 1 over sine. And look at that. Oh, that's an ugly sine squared. So you get sine squared x times 1 over sine squared x. Again, same thing. So those cancel, and you get 1 equals 1, which is what we were trying to prove. Okay. Again, there was other ways. Let's say you forgot about that property, the Pythagorean property, Pythagorean identity, I should say. And you were like, I'm stuck. I don't know what to do. Change everything to sines and cosines, right? So you say 1 plus, and then this would be cosine squared x over sine squared x. And then if you multiply this out, you get sine squared x times 1, which is just sine squared x. And then you get sine squared x times cosine squared x over sine squared x. And look at that, the sine squareds cancel. So you get sine squared x plus cosine squared x. And this is the one Pythagorean theorem or Pythagorean identity that I said, like, you have to know. Sine squared plus cosine squared is 1, which is what we wanted. And there you go. Okay, and now this last one, you have tangent squared of theta times cosine theta, and then over 2 secant of theta equals 1/2 sine squared theta. So, you look at this, and I definitely say that left side is more complicated. So let's go ahead and start. I see a lot of tangents, secants, and a cosine, and I'm trying to get sine. So I'm going to go ahead and change everything to sine and cosines and hope some really nice things happen. So I get, oops, 1 second. So sine squared over cosine squared theta, because it's tangent squared, that's just being multiplied by cosine theta. And then this is 2 times 1 over cosine theta. Now you can do more than one property at a time, as long as they're not affecting each other. So you can kind of see here, I changed tangent to sine over cosine. I changed secant to 1 over cosine. They didn't affect each other, so it's okay to do those at the same time. So now we start canceling some stuff out. So cosine squared times cosine means one of those cosines go away in the denominator, and this cosine goes away. So you have sine squared theta over cosine theta over 2 over cosine theta. Now, you could have written this as 2. Maybe I'll do that. There we go. Because, right, it'd be 2 over 1 times 1 over cosine theta. And so now you have a fraction divided by a fraction. So you keep the top the same, and you multiply by the reciprocal, which is cosine theta over 2. So that cancels with that. This really just becomes 1/2, which is exactly what we wanted. It's just in the wrong order. So I just change the order when I write it in the next step. So 1/2 sine squared theta, which is exactly what we wanted. And I'm done. And there are ways of doing all of these, lots of different ways. And if you, like I said, if you do it a different way, that's totally fine. And you can even try doing them different ways. But yeah, that's pretty much it. So we'll do more practice of these throughout this week. So yeah, thanks for watching, and have a